Hello, today we are going to explain the asymptotes. We have three types of asymptotes: vertical, horizontal, and slant, which is also called oblique. So vertical, horizontal, and slant. Let's begin with the vertical asymptote. For this function, y equals 1 over x, which is equal to x power negative 1. Here, the sketch of this function is like this. I think we all know it. So, y equals 1 over x. Here, the y-axis, or this line, x equals 0, is a vertical asymptote for this function, y equals 1 over x. Why? Because as the function tends from the right to the left, tends to this line from right and tends to this line from left. This is not the correct. This is not how we could identify the asymptote. But the asymptote is that the function tends to align. It doesn't intersect it. Tends to align, but it doesn't intersect it. An asymptote could be like this, or a vertical asymptote could be like this for a function. Okay? A long function. So let's concentrate here. How we prove that the y-axis, or x equals 0, is a vertical asymptote? We let the denominator of the function equals 0. So here x equals 0, and here it is the function of the asymptote or vertical asymptote line. X equals 0. In other functions, it may be x equals 5, x equals negative 2, anything else. But it will be x equals 0. Why? Because it's a vertical line. So x equals constant. The second type is the horizontal asymptote. For the same function, this function has a vertical asymptote and a horizontal asymptote. If you concentrate, we will see that this is a horizontal asymptote for the function y equals 1 over x, which is the x-axis. Okay? How can we get it? Let's see from the sketch. We see as x tends to infinity, the function tends to touch this line which is the x-axis. Here, which is y equals 0 in this function, it may be y equals 2, y equals 3 in other functions. So again, as x tends to infinity, the function tends to this line. As the x tends more to infinity, the function tends more to its horizontal asymptote. So, to translate this into an equation, we say that limit when x tends to infinity of the function. The function here is 1 over x. So limit when x tends to infinity of 1 over x. We get that it's equal to 1 over x here equals infinity, or tends to infinity. 1 over infinity equals 0. So the limit equals 0. We say that y equals 0 is the horizontal asymptote. Again, in other functions, it may be y equals 2, y equals negative 2, negative 5, and so on. Let's move to the third type, which is the slant asymptote. start, let's consider that we have a function f of x equals a fraction of, up there is a function in x which is called p of x, and down another function in x which is called q of x, where the degree of p of x is greater by 1 than that of q of x. This, and the degree means the highest power of x in the function. If here the highest power is 2, so here must be 1 to get a slant asymptote. X power 5, x power 4. For example, x power 5 plus 2, x minus 1, and here x power 4. So the greatest power of x here is 5 and 4, so we can predict that we will get a slant asymptote. Why? We will explain now. If we say that, do you remember the long division? Simple case, 15 divided by 7 equals 2. 15 divided by 7 equals 2, and we have a remainder, and this 7 times 2 equals 14. We change the sign, it's negative 14, so the remainder is 1. So we can write this as 15 divided by 7 equals 2 plus 1 over 7. This is called remainder. We give it the symbol R, and this is the quotient. So in this case, if we make a division for it, p of x divided by q of x. Do you remember this condition? The greatest power of this function is 1 more than the greatest power of this function. So the division will predict that it will be mx plus c. C may be equal to 0, a number, anything, any real number. So here mx plus c, and there will be a remainder. The remainder here, we call it r. Here the remainder was 1 over 7. Here it will be another, any value. But the main important thing is that the quotient equals mx plus c, which is a function of a line. To get a line, the main function of a line is y equals mx plus c. So this is a function of a linear line. That is the reason that the p of x, the degree, should be or must be greater than by 1 than the degree of q of x by 1. Okay? To get the quotient equals to a linear line. So here, if we say y or f of x, let's say f of x equals mx plus c, the quotient here we set 2, here it will be mx plus c plus the remainder over q of x. Here we said remainder over the 7, the number which we divided by, or the function which we divided another function by it. So plus r over q of x. Concentrate here, please. As x tends to what? To infinity. Can you predict with me the value of f of x or y? Please try to answer it alone. As x tends to infinity, q of x is a function in x. So as x tends to infinity and the degree of r must be smaller than the degree of x, and in a lot of times it will be, the degree here will be 0, so it will be a constant. Maybe it's a number, but other times it may be a function in x, but the degree of r is less than the degree of q of x due to the division. So as x tends to infinity, therefore y equals f of x equals mx plus c plus 1 over infinity equals mx plus c plus 0. Therefore y equals f of x equals mx plus c. Here we derive this. So we can say that the quotient is the function of the slant asymptote. The slant asymptote. It's the function of the slant asymptote. Remember that this is a function. This is a slant asymptote for it. The function is mx plus c. It's function of any line, but for a certain function we get its slant asymptote by the division, and the quotient is the slant asymptote. So the function, I want to say something. A function may have one asymptote or two asymptotes. Why? One, it may have a vertical, slant, or horizontal. Or two, may have vertical, as here, vertical and horizontal. Vertical asymptote and horizontal asymptote. But why the function can't have three asymptotes? This is wrong. Sorry for the interruption. So let's continue. Here we get that after division by x power 2 in the numerator and the denominator, it will be 1 over 1 plus 3 over infinity, because x squared equals infinity as x tends to infinity. Here. So the value will be equals to 1, which is a constant. 1 equal, which is a constant. So to get a horizontal asymptote, the degree of the numerator should be less or equal to the degree of the denominator. Here, when it was equals to 0, it was less, and when it became a positive or negative integer or fraction or any number except 0, when the numerator, the degree of the numerator equals the degree of the denominator, while the condition for the slant asymptote was that the degree of the numerator should be greater than the degree of the denominator by 1. Hope you understand this lesson. It's Omar Barakallah. Thank you.